section today. We have about a half hour to go. 22 minutes. Let's go ahead and do this. This is section 1.7. And we'll call it absolute value equations and inequalities. Know what absolute value means? Yeah. That's exactly what it is, right? The absolute value of x just means x units from 0 on a number line. So we're going to build from that definition in order to get answers to our problems coming up here. The absolute value of x is equal to 2 means what numbers are 2 units from 0 on a number line. To a negative 2, right? If you were to graph this, here's 0. 2 units this way is 2. 2 units this way is negative 2. That's why the answer for this problem would just be x is equal to 2 and x is equal to negative 2. Where it gets interesting are the inequalities. So if I gave you an inequality, the absolute value of x is less than or equal to 2. What this means is what numbers are less than or equal to 2 units from 0 on a number line. Let's draw a number line. There's 0. What numbers are less than 2 units away from 0? All of these and all of these. All of those numbers are less than 2 units away from 0 on a number line. Does this look like an and or an or inequality? That's important because of what we just talked about in the last section. If the absolute value of x is greater than or equal to 2, what this means is what numbers are greater than or equal to units from 0 on a number line. Numbers are more than 2 units away from 2 on a number line? Or I'm sorry, what number? I'm getting excited here. I like this stuff. What numbers are greater than 2 units from 0 on a number line? These numbers are. So are these numbers. Does this look like an and or an or problem? as we saw in the last section, the answer is totally different depending on if it's an and or an or problem, so we have to make sure we know which one is which. There's a little bit of a cheesy way to differentiate the two. I'll tell you in 1 second. Yes? Yeah, for these kind of problems, absolutely. Right? One way that we could remember this is when we go to solve the problem and we get absolute value by itself. This is less than sum. It's kind of silly. But if you read it out, less than, one way to remember that it's an and problem. As opposed to great. You want to say it? Great. There it is. That's one way to remember it. The answer is totally different depending on if it's an and or an or problem. And that's kind of a silly way to make sure that you get it right. That only applies if it is an inequality. For regular equations, we don't have to worry about that. So let's finish class off by going through some of these examples. The directions are going to be to solve. And let's start with an absolute value equation. 3x minus 4 is equal to 11. Now remember what we started off this section by talking about. This number, whatever it is, could either be 11. What number is 11 here with 0 on number? It could either be 11 or this could be negative 11. That's where it comes from. The way that we write this is we could keep the left side always exactly the same. We say 3x minus 4 is equal to 11. Add 4 on both sides. Divide by 3. We get x is equal to 5. The way that, remember we said it could either be 11 or negative 11, right? So the other side, we take the opposite of the right. So the right side's 11, so we say 3x minus 4 equals negative 11, and then we just solve that. If you add 4 to both sides, 3x is equal to negative 7, dividing by 3. That should be negative 7/3. If we plug in either of those numbers for x, we get the absolute value of 11 or the absolute value of negative 11, which is equal to 11. I don't know where that's coming from. All right. Also, when we're solving absolute value, we want to always isolate the absolute value. And then we separate. Separate. I'm going to try to spell it. Did I do that right? I think so. Every time it comes up, I always get mixed up. But we isolate absolute value and then we separate. Let's take a look at another example like this. What if we had 2 times the absolute value of x minus 3 plus 1 is equal to 5? don't want to start separating it yet. You want to isolate that absolute value. Let's subtract 1 on both sides. By 2. Now we have the absolute value completely by itself. And from here we can separate. Remember, we're keeping one side exactly the same. The other side we take the opposite of the right. Five, and x would be 1. That's a little bit of a rundown how we handle absolute value equations. We'll work on absolute value inequalities in a little bit. I also want to point out over here that we never distribute into absolute value. You don't want to do this. What you want to do is you get the absolute value by itself, and then once it's completely by itself, then you break it up. Let's spend a little bit of time on inequalities. So what if we had -2 times the absolute value of x plus 1 is greater than or equal to -6. Is this an and or an or problem? And it's a little tricky. We don't know yet because it's not isolated. First thing we have to do is isolate it. So let's isolate first. What that means is we have to get rid of that -2. So let's divide both sides by -2. The absolute value of x plus 1 is less than or equal to 3. And now that it's isolated, it says the absolute value of x plus 1 is less than 3. So we talked about how to handle this. This is an and problem, meaning that we're looking for overlap when we go to graph it. One side we keep exactly the same, so let's go ahead and do that. X plus 1 is less than or equal to 3. X is less than or equal to 2. On the other side, we talked about taking the opposite of the right. But we also, when we have an inequality, you can't just multiply 3 by -1 and not change the sign. So there's a couple of rules that are into play here. We also have to switch the inequality. We get x plus 1 is greater than or equal to -3. We can just subtract 1 on both sides. We get x is greater than or equal to -4. So let's go ahead and graph it. Remember, we're looking for overlap. All numbers that are less than 2, all numbers that are greater than -4. We're just looking for overlap here. So it looks like we're looking at numbers from -4 to 2. This would be the answer. If it was an OR problem, what would the answer be? If we're just looking for coverage, what would you say is the final answer? Yeah, negative infinity, positive infinity. The whole thing is covered, right? So it is important that we know the difference between and OR. Yeah, we could use 2 brackets like this. If it's ever infinity, we always have to use parentheses. What about if we had a problem like this? Say the absolute value of x minus 1 minus 4 is less than or equal to 2. We don't know if it's and or yet. We have to get the absolute value by itself. Let's add 4 to both sides. Absolute value of x minus 1 is less than or equal to 6. Or problem. Less than, right? So this is an and problem. Separate it. This one is less than or equal to 6. We keep that exactly the same. The other side, we do 2 things. We take the opposite of the right. Have to switch the sign. If x minus 1 is greater than or equal to -6, we add 1 to solve it. Plus, this is an and problem. We're looking for overlap. It looks similar to the last problem we did, where it overlaps from -5 to 7. 2 or 3 more problems I wanted to do with you before we close out class today. What about if we had a problem like this? Absolute value of x plus 2 3 is greater than or equal to 2. We'll add 3. You can see that this is an OR problem. It would be greater than or equal to 5. Or, meaning we're looking for coverage, x plus 2 is less than or equal to -5. X is less than or equal to -7. Let me go to graph this. Here's 3. We're looking for all numbers less than -7 or equal to, and we're looking for all numbers greater than or equal to 3. So this would be an example of an OR problem where we have to combine this section of the graph with this section of the graph. A couple more problems here. What about if we had the absolute value of x plus 1 is greater than negative 2? Well, the absolute value is isolated. We could separate it. Is this an and or an or problem? We're just looking for coverage. One on both sides should be greater than negative 3, or it should be less than 1. Go to graph it, it'll look like this. What would be the best way to write this answer if we're just looking for coverage on the graph? Yeah, the whole thing is shaded. So we would say for our best answer, we go from negative infinity to positive infinity. One interesting thing about this problem is asking the absolute value of a number. One is greater than negative 2. Put any number in for x, the absolute value of it always going to be greater than negative 2. From scratch. Finish with one last example tonight. What if we had the absolute value of x plus 2 is less than negative 3? So this is another example that's a little different than the normal type of problems that you'll see. We go to separate it. Is this an and or an or problem? This is an and problem. We're looking for overlap. We go to graph it. If you isolate the variable on the left-hand side, you get x is less than negative 5. On the right side, remember, we're doing those two things. We're switching the inequality. We're also taking the opposite of the right side. That x is greater than 1. And we're looking for overlap. Where's the overlap on the graph? Solution, right? So the way that we say no solution, we just put a 0 with a line through it. Make sure when you're doing the homework with my math lab, don't put 0. That's a different answer than that. You have to find the one that says no.